Okay, now we're going to look at integrals that have discontinuity somewhere. We're going to go ahead and approach it very similarly when we had limits of infinity. So notice if you look at the first integral that x equals 3 is undefined. So we really can't plug in 3 as one of the bounds because it doesn't exist on this graph. So we're going to do it very similar to how we did with infinity. I'm going to rewrite it as a limit statement as we approach 3. So I'm going to approach 3 from the left-hand side. I can't approach it from the right because you're going to get to the asymptote, so I can get closer and closer to 3 from the left. So let's rewrite this. And typically when we do antiderivatives, if I see something on the bottom that's not raised to a power of 1, remember we want to bring it to the top. So I'm going to go ahead and do the rewrite like this. This is a u substitution problem. Notice your u is 3 minus x. Notice your du is negative 1 dx. So if you want to do the rewrite, then you would need a negative 1. So I need the reciprocal, which is still negative 1. So this is u to the negative 1/2, and then I have a du. So let's take the antiderivative. So don't forget this is still that negative sign. So I've got negative, I'm going to add 1. Dividing by 1/2 is the same as multiplying by 2. And then these are my bounds. Okay, let's go ahead and plug back in my u substitution if you did it that way. So really you have square root of, plug back in the u, 3 minus x from 0 to t. Okay, now let's go ahead and plug it in and see what we get. I'll go ahead and plug in the bounds first. So 3 minus t plus 2 square root of 3 if I plug in the 0. And now let's take the limit. If I plug in 3 for t here, this approaches 0, so I have 0 plus this, the limit stays 2 square root of 3. So we say this integral converges to 2 square root of 3. Okay, now let's look at the next one. Very similar. Notice that this one has a discontinuity at 0, right? We can't plug in 0 on the bottom. So I'm going to rewrite this with the limit statement. So I'm going to approach 0 from the right side, so numbers to the right of 0. Same thing, so we're going to go from t to 1 of 1 over x dx. This antiderivative is just the natural log. So I got natural log of x from t to 1. And you have to keep writing that limit statement until you actually take the limit. Okay, so now let's take the limit. This is going to become 0. When I plug in 0, you have to think about what's happening to the natural log graph. So this is where if you know what the graph looks like, this is helpful. So the natural log graph looks like this. So notice as you approach 0 from the right-hand side, you are going this direction, and notice the graph just goes to negative infinity. So if one of these pieces is infinity or negative infinity, it really doesn't matter what this is. This is not going to approach a number. So we say this integral diverges. Okay, last one. Notice that there is a discontinuity at x equals 3, but notice that 3 is between 0 and 4. So we're going to have to split this up into 2 separate integrals. So I'm going to go from 0 to 3, and then go from 3 to 4. And again, I can't really plug in 3 because it doesn't exist on that graph, so I need to rewrite both with the limit statement. So I'm going to do as limit as we approach 3 from the left side here, because we're going this way. And then this one I can also rewrite, and you can use the same letter if you want, you don't have to. This one I'm going to approach from the right side. Okay, and typically when we do antiderivatives and you have things on the bottom that's not raised to a power of 1, remember we go ahead and bring it to the top. So keep writing that limit statement. I have not taken the antiderivative yet, I'm just doing a rewrite. And this is just going to be your power rule. Your u is x minus 3, your du is 1, so you're not missing anything. So the antiderivative of x minus 3 squared is just going to be x minus 3 to the negative 1. And then, oops, I forgot to put my bounds here. So this is going to go from 0 to t, 0 to t, 0 to t. Here, this is going from t to 4, t to 4. This is the same antiderivative. And we're going to go from t to 4. Okay, let's go ahead and plug in our bounds and see what happens. So if I plug in 3 here, okay, let me rewrite this one more step. This is really 1 over x minus 3. So notice if I plug in 3 here, you're going to end up with a 0 on the bottom. So if the bottom of the fraction gets bigger and smaller to 0, the whole fraction gets bigger and bigger. So this whole fraction is going to get to infinity. So if one piece is infinity, it really doesn't matter what this piece is, because infinity plus or minus anything is still going to give you to infinity. So we can just say that I know that this is going to diverge. And then that's it. You don't have to tell me whether it's infinity or negative infinity or anything like that.